In this lesson we're going to talk about the law of sines, which is going to be what we need whenever we have a triangle of the case SAS or SSS. Cases 3 and 4 in this book. So let's take a look. One thing to keep in mind while you're dealing with triangles is that the sum of the lengths of any two sides must be greater than the length of the remaining side. And you'll know this if you've ever seen a path, a sidewalk path that went like this. And what do? You don't follow the path, you take a shortcut because you know that the straight path is shorter than the bent path. Now, this helps us if we're, just use common sense when we're checking our triangles. You can just tell at a glance sometimes if you've got things mixed up. Suppose that we had figured out that this side was 8 and this side was 10, but that we had this remaining side somehow is 35. Alright, well, common sense will tell you that that can't be right because these two add up to 18. If this one is a shortcut, it's got to be less than 18, so 35 couldn't possibly be right. So this will just help us catch mistakes here and there. So first off, we're going to derive the law of sines, or cosines rather. What we're trying to do is come up with a formula for this length. Okay, if I have a triangle laid out on the coordinate system like this with B at the origin, I know that side A ends at A, 0. We want to try to find this point here. Now this point comes from, if you drop a little perpendicular here, you can say that the cosine of B is adjacent over hypotenuse, so that'd be x over c. And the sine of B is opposite over hypotenuse, so that'd be y over c. And if we solve those two relationships for x and y, then we can say that this point here, instead of just being plain x and plain y, we can say that it is c cosine b comma c sine b. So the x coordinate is c cosine b and the y coordinate is c sine b. Now that we have our two coordinates labeled, we're just going to use the distance formula from algebra to find out how long this distance is. So here's the distance formula the way you might have seen it in an algebra textbook. And so the first thing I want to do is get rid of that radical. So let's square both sides. So d squared now equals x2 minus x1 squared plus y2 minus y1 squared. Okay, now the distance we're interested in is side B. And that's going to be this x value minus this x value. So cosine or c cosine b minus a all squared plus this y value minus this y value. So c sine b minus 0 all squared. If we FOIL this out, square that binomial, first times first is c squared cosine squared b. The middle term will be 2ac cosine b. It'll be negative. And last times last will be plus a squared. And then here, I don't have to go through all that because this second term is 0, so it's just going to be plus c squared sine squared b. Now, let's go ahead and put the c squared stuff together. We've still got this minus 2ac cosine b thing hanging out there. And notice that both of these contain c squared, so we'll factor out the c squared. And cosine squared plus sine squared is 1. So that's just going to collapse into a 1. And now we have c squared plus a squared minus 2ac cosine b. And this is the law of cosines. It is just a way to find a missing side of a triangle that's not a right triangle. Notice how similar it looks to the Pythagorean theorem. It's just that it has this extra term. And in the case of a right triangle, say if B were the hypotenuse, which I know normally C is, but if B were the hypotenuse, then angle B would be a 90-degree angle, and the cosine of 90 degrees is 0. The cosine of 90 degrees is 0, and so this whole term would go to 0. So there are 3 different forms of the law of cosines, depending on which side you want solved for. Notice that each one of them is the side squared is equal to the sum of the squares of the other 2 sides minus twice the product of those 2 sides times the cosine of the angle between them. Okay? The sum of the squares of the other 2 sides minus twice the product of those 2 sides and the cosine of the angle between them every time. So if you want b squared, you're going to do a squared plus c squared minus 2ac cosine b. If you want c squared, you're going to do a squared plus b squared minus 2ab cosine c. And these 3 are on the formula sheet that you get on test day. And as we pointed out a while ago, if c is a 90-degree angle, then the third term will contain cosine c, which is 0, and you get the Pythagorean theorem because that last term goes away completely. And here's our first example. We want to find the distance between point A and point B, and we know the length of side B and the length of side A, and we know the angle between them. So we want to find C. Now look at the setup we've got here. We've got side, angle, side. So remember that's case 3. If you have case 1, that's law of sines. Case 3 is going to require us to use the law of cosines. And since we want to find side C, let's use the version that is already solved for c squared. So that will be a squared plus b squared minus 2ab cosine c. And just plug in the numbers that you have for a and b and the cosine of c. And just plug it all in the calculator. And this is what you should get once you've plugged it all in. And of course, this is c squared, so do the square root to get c, and I'm getting 628.1 meters. But try it on your calculator so that you know that you're sure you can get it to come out right. Okay, here's example 2. It says solve the triangle if A is 42.3 degrees and B is 12.9 meters and C is 15.4 meters. And here it is already drawn for us. Now, always look first to see what case you're dealing with. This is side, angle, side. So we know right away we'll have to use the law of cosines. And since we're looking for side A, let's choose the version of the law of cosines that starts with a squared. So a squared equals b squared plus c squared minus 2bc cosine c. And I'm just noticing that I'm missing a square here. Okay. So let's plug that in the calculator and get a value for a squared. A squared is about 109.7, and that means A is about 10.5. Okay, once you use the law of cosines to find the missing side, now you have enough information to use the law of sines, because see, now we have an angle and the side across from it. That enables us to use the law of sines, which is of course a little easier to handle. So now we know all 3 sides, and we're going to want to find one of the missing angles. Here's the thing. If you think about using the law of sines to find a missing angle, you're going to end up doing an inverse sine function at the end. And you're going to end up doing an inverse sine on a positive number because your sides are positive. This is an acute angle, so its sine is positive. And the inverse sine of a positive number is going to give you something between 0 and 90. But what if one of these angles is supposed to be obtuse? The calculator will not be able to tell you that. So whenever you use the law of sines to find an angle, make sure you are using it to find the smaller of the two angles. In this case, B is 12. The side B is 12.9 and side C is 15.4. Therefore, angle B is smaller than angle C because side B is smaller than side C. So I'm going to use the law of sines to find angle B rather than angle C. Okay, this is just writing out what we've already talked about. So notice this time I've got my sine in the top rather than the bottom. That's because my unknown is an angle this time. So the sine of C over side C equals the sine of A over side A. And now I'm going to multiply both sides by 15.4. And let's go ahead and get a value there. If you plug all this into the calculator, you get about 0.9871. And do an inverse function. The sine inverse of this number will give you about 80.8. Okay, now to find angle B, all we have to do now, since we know two angles, is just subtract from 180, and B is about 56.9. So let's kind of summarize what we were saying before. The law of sines cannot tell you if an angle is acute or obtuse because sine inverse cannot return an obtuse angle. Sine inverse will give you something less than 90 every time. Sine inverse of a positive number will be between 0 degrees and 90 degrees. Therefore, if you need to use the law of sines to find a missing angle, you want to find the smaller of the two missing angles. That way, since a triangle contains at most one obtuse angle, you're guaranteed to be finding an acute angle. Now, on the other hand, if all three angles are unknown, you'll have to use the law of cosines to find the first angle. And if you're going to use the law of cosines to find the first angle, then make sure you're finding the only one that could possibly be obtuse. So since cosine inverse can return an obtuse angle, use the law of cosines to find the largest of the three angles. That way, if there is an obtuse angle there, you'll find it first. So bottom line, if you are using the law of sines to find an angle, find the smallest possible one. And if you're using the law of cosines to find an angle, choose the largest possible one. Okay, here is a triangle that has three sides known and no angles. And notice they did not draw it for us. So the very first thing I would do is draw myself a triangle. And let's see, we don't know any angles. There are three unknown angles, so we're going to have to use the law of cosines. This is a side, side, side. We'll use the law of cosines to find the first angle, and let's make it the biggest one. Now, side C is the biggest side, so angle C is going to be the biggest angle. So we'll use the law of cosines to find angle C. Here is the law of cosines that contains the cosine of C, and we'll plug in the sides that we know. Okay, now let's solve this the same way you would solve an algebraic equation. Solve it for cosine C. So we'll subtract 9.47 squared from both sides, subtract 15.9 squared from both sides. Okay, now I have this coefficient times cosine C. I want to divide this away. So let's divide both sides by that number. And this value here is going to be the cosine of C. Now when you put this in the calculator, do 21.1 squared minus 9.47 squared minus 15.9 squared and press enter or equal. Okay, now divided by, for the big fraction bar, divided by, put the whole denominator in parentheses so that it divides by the whole denominator, not just the first number. So divided by parentheses, -2 times 9.47 times 15.9, close the parentheses, press equal. If you've done it correctly, you should get cosine C equals -0.3411. Now don't take my word for it. You should punch this in your own calculator and make sure that you get it, because if you don't, you need to figure out how to make it work. And to get the angle that goes with this, we'll do inverse cosine. Inverse cosine of this number will give us an angle of 109.9 degrees. Now, here's where we were. We just found the angle C. I drew it on a new page for us. And now we want to find angle A and angle B. Now both of these two angles are guaranteed to be acute because the only possible obtuse one we've already found. And okay, so now it doesn't matter because they're both acute. It doesn't matter which one we find next. So we use the law of sines to find either remaining angle. And I choose to find angle B. So sine of C over side C equals sine of B over side B. And we're going to multiply both sides by 15.9. And now get a number for that. And inverse sine of this number will tell you the angle. And this is about 45.1 degrees. And now to find the third angle, there's no need to use another law because now we know two angles. We can just subtract from 180 to find the remaining angle. Now, lots of times on tests, I give a problem like this and I see people use the law of cosine 3 times to find the 3 missing angles, and it's just a lot of unnecessary work. Use the law of cosines once to find the largest angle. That's the most work. Then use the law of sines because it's easier to find one of the remaining angles, then subtract to find the third angle. And here's one more example. We have this truss situation. We want to find B to the nearest degree. So this is another side, side, side. And so we'll have to use the law of cosines to get started. Now, ordinarily, I would want to use the law of cosines to find angle A. But since I don't have to find angle A, I don't have to find all the angles, I'll use the law of cosines to find angle B. So since I want to know angle B, I'll use the cosine, the one that contains cosine of B. Plug in our numbers. 6 squared equals 11 squared plus 9 squared minus 2 times 11 times 9 times the cosine of B. Alright, now I want to isolate cosine of B, so let's subtract these two numbers from both sides. We end up with 6 squared minus 11 squared minus 9 squared. Divide both sides by that product, that coefficient, so that cosine of B is isolated. And cosine of B is 0.8384. So the inverse cosine, or the angle, is 33 degrees. The inverse cosine of 0.8384 is 33 degrees. And I see that I have a little typo here. That should just say B, not cosine of B. To summarize, if you have a case 1 triangle, which is an SAA or an ASA, you can find the only unknown angle using subtraction, and you can use the law of sines to find the remaining sides. This is the easiest of all possible worlds. If you have an SSA, things are a little more complicated because more than one triangle is possible. Then you would go through these steps to verify that you have a triangle at all. If you have a case 3, then that's an SAS, and you'll have to use the law of cosines to find the missing side. Use the law of cosines to find the missing side. Find the smaller of the two remaining angles using the law of sines, and then subtract to find the third missing angle. And then if you know all 3 sides, you'll find the largest angle using the law of cosines. Find either remaining angle using the law of sines and then subtract for the third.